In this section, we're going to talk about airside design. Everything that we're going to be covering is in the ASHRAE handbook. So these are all guidelines that are available to you from ASHRAE. How you apply them, however, is absolutely critical and quite frankly can make or break the job from an air quality standpoint. So it's absolutely critical when we're doing the design on the air side of a pool that we are very, very careful and very deliberate about how we lay out the air distribution so that we deliver a very good air quality and a condensation-free facility. The supply air CFM for any indoor pool is dictated by the room volume. ASHRAE recommends 4 to 6 volumetric air changes per hour. That's a good amount of air to use. You never want to go light on your supply air. 4 to 6 volumetric air changes is a good amount of air. Gives you lots of air to work with to make sure that you're turning over the room and addressing any areas of concern like exterior windows where you want to make sure you've got a good airflow to keep them from sweating in the wintertime. And it's enough air that you'll have plenty left over to get some air down into the breathing zone and down to the deck area. Air distribution, if you're going to ask me what is the most important aspect of HVAC design in an indoor pool, this is it. As the HVAC designer, this is 100% on your shoulders to make sure that this air that we've dehumidified and treated and filtered, that's good air quality, gets to where the people are. We absolutely have to make sure when we're laying out the air distribution that this good air gets down to where the people are. We need to make sure that our air throw from our diffusers, if they're overhead perimeter ductwork, gets all the way down to the deck area where the people are. This is the most important piece of the IAQ, indoor air quality puzzle. Some additional airside design concerns are making sure that we get a little bit of airflow down at the water if at all possible. That's important as far as moving the chemicals away so the swimmers aren't breathing those high concentrations of chlorine. And then when we're laying out the air distribution in general, we want to make sure that our air pattern is good. And if we've got high overhead perimeter ductwork, we want to make sure our return, if at all possible, is sort of complementary to that. So overhead perimeter ductwork, if you can put your returns down low, that's going to create an overall air pattern that works nicely. So again, when you're laying out the ductwork, it's a bit of an art form. You want to visualize the air pattern you're creating because it's essential that we get the air movement down to the water and to the breathing zone of the people. It's absolutely critical. So this is where some of the key design considerations are vital, but we also have to make sure that we're not short-circuiting, so make sure that you don't have any supply duct that's really close to the return. Again, it's absolutely critical that we establish a really good air pattern in the space. The amount of outside air you need to introduce in a facility is code driven. You have to satisfy your local codes. Most have adopted ASHRAE Standard 62. That's enough outside air to give you good air quality, assuming you've done a halfway reasonable job on your air distribution. There's no need to use more. Outside air is expensive. Don't forget, an indoor pool is 82, 85 degrees Fahrenheit, so if you're in a northern climate, you might have to heat that 100 degrees just to get it neutral. So outside air is expensive, and there's really no reason to go overboard. If you're doing a decent job on your air distribution, the amount of outside air required by Standard 62 is plenty. The baseline calculation is 0.48 CFM per square foot of pool and wet deck area. Wet deck has an interpretation from Standard 62 of about a 6-foot perimeter around the pool. And the reason for considering wet deck instead of the entire deck area is dry areas of the deck, predictably dry areas of the deck, don't really factor into any evaporation. So there's no chemical off-gassing ever going to happen from dry areas of the deck. So you don't really need to factor in the total square footage of that deck area because your outside air volume is going to get pretty big. So once you've established your 0.48 CFM per square foot of wet deck and pool baseline outside air requirement, if you happen to have a spectator area, that in addition to that baseline calculation, during a swim meet, you need to include 7.5 CFM per spectator on top of the baseline. If you don't have a spectator seating gallery, your baseline calculation is definitely adequate. You do need some exhaust air in your space. ASHRAE recommends you keep the space negative 0.05 to 0.15 inches water column. So you want your room a slight negative. The combination of outside air and exhaust air helps with the continuous dilution of the room air. So any chemicals that are coming off of the water, you've got continuously outside air and exhaust air going on, so it helps dilute the space. So definitely something you want to do. One of the things you can also do from an air quality standpoint is if you've got a hot tub, they spew a lot of chemicals. They've got the bubblers going on, the water's very warm, so you've got a lot of chemicals getting off-gassed into the space. If you've got an exhaust air requirement anyway, you might as well try to put an exhaust air intake right over the hot tub, and then you can sort of source capture those chemicals while they're off-gassing and get them out of the room before they have a chance to diffuse and kind of wreck the air quality. So some spot exhaust air on the warm bodies is definitely a way to go from an air quality standpoint. But again, the room needs to be just a slight negative. You don't want it pressurized, because then you would push kind of the pool smell throughout the rest of the building. So just a slight negative pressure on the room, and you've got a good air quality as well. Condensation is a problem in indoor pools. The room is 82 degrees, 50% relative humidity, so you've got a high dew point, 62 to 65 degrees. So it stands to reason any surface in the room that's a little bit cool is going to condense very quickly. Normally, windows don't have a very strong R value, so they get cold very quickly. So your first cool day in the winter, the surface area of your glass can get cold. Obviously, that's undesirable. Skylights are the same thing, fire doors as well. So one of the things we can do from an airside standpoint is we can actually deliver supply air to the windows or the skylights or the fire doors and warm them up a little bit. As soon as you've heated them to above 62 degrees, get 63, 64 degrees, you've solved your condensation problem. So from an air distribution standpoint, in addition to obviously wanting to get air into the breathing zone, we want to identify any of these areas of condensation concern and blanket them with warm supply air. That's how you solve your condensation problem on an indoor pool.